Evolution doesn't make mistakes. It doesn't do random. Every quirk, every apparent flaw in your biology exists because, at some point, it kept an ancestor alive long enough to pass on their genes. So here's a question that challenges everything you think you know about human history. Why did we lose our fur? Every other primate is essentially wearing a built-in winter coat. Gorillas, chimpanzees, orangutans. They're all covered in thick, protective hair, even those living in steamy, humid jungles. And then there is us. Naked, sweaty, and seemingly vulnerable. We actually have the same number of hair follicles per square inch as a chimpanzee, but ours are so fine they are virtually invisible. We are the only mammal on Earth that has to deliberately harvest the skins of other animals just to survive a mild breeze. This isn't a minor cosmetic difference. This is one of the most radical biological redesigns in evolutionary history. And for over a century, the world's top scientists have been fiercely debating exactly why it happened. The first theory that probably comes to mind is heat. We evolved in Africa. Africa is hot. Less fur equals better cooling. Case closed, right? Wrong. Here is the problem. Elephants don't have fur. Hippos are practically hairless. But they didn't evolve on the open savanna chasing down antelope. They evolved in water and mud. Furthermore, if you look at the fossil timeline, the heat hypothesis starts falling apart. Our ancestors were already walking upright in open grasslands around 4 to 6 million years ago. But genetic evidence, specifically from the evolutionary divergence of human head lice and body lice, suggests we didn't lose our fur until much later, roughly 1 to 2 million years ago. So, for millions of years, we were upright, fur-covered, and living in the exact same brutal heat. If losing fur was such an obvious advantage for thermal regulation, why did it take millions of years to happen? Evolution doesn't wait around for good ideas. Either the heat theory is incomplete, or a much more complex driver was forcing this change. Enter the Aquatic Ape Hypothesis. Proposed in the 1960s, this theory argues that our ancestors spent a significant amount of time in water. Proponents point to our layer of subcutaneous fat, which acts like blubber. We can hold our breath. We have a mammalian dive reflex that slows our heart rate underwater. And hairless skin dramatically reduces drag in water. It is a seductive idea, but mainstream anthropology has largely rejected it, and for good reason. There is zero fossil evidence to support it. No aquatic adaptations in the skeletal record. No signs of shoreline living in the early archaeological record. Every so-called aquatic trait in humans has a perfectly logical terrestrial explanation. But the theory refuses to die. Why? Because it points to something very real. We are weirdly, uniquely over-adapted for sweating. And that doesn't make sense unless something dramatic happened to our thermoregulation. Which brings us to the most scientifically supported answer. We didn't lose our fur just because of heat. We lost it because of sweat. Specifically, Eccrine sweat glands. These are the glands that pump out a watery, salty fluid to cool the skin through evaporation. Most mammals rely on apocrine glands, which produce oily, scent-based secretions. We have those too, but they are completely dwarfed by our eccrine glands. Humans possess between 2 and 4 million of them, more than any other primate by an order of magnitude. Here is the kicker. Fur blocks evaporative cooling. You cannot sweat effectively through a thick coat. This leads to the endurance running hypothesis. As our ancestors transitioned into persistence hunters, sweating became our ultimate biological superpower. We could outrun a gazelle, not because we were faster in a sprint, but because we could keep moving long after the prey collapsed from heat stroke. This theory is backed by serious biomechanical evidence. Our spring-like Achilles tendons, our narrow waists, our massive gluteus maximus muscles, and even the nuchal ligament that keeps our head stable while running. All of these are specialized adaptations for sustained running in hot climates. And remarkably, they all evolved around the exact same time we lost our fur. But wait, there is a massive, glaring hole in this theory that few people talk about. If losing fur was so advantageous for running and hunting, why didn't other savanna predators do it? Lions are covered in fur. Cheetahs have a thick coat. Hyenas are essentially walking carpets. They all hunt in the same heat. They would all benefit from superior cooling. And yet, they kept their fur. The answer lies in how they hunt. They sprint. They ambush. They do not run marathons. But here is the uncomfortable truth. Early humans weren't exactly dominating the food chain either. We weren't apex predators. We were scavengers and opportunistic hunters at best. The idea that we evolved this entire metabolically expensive thermoregulatory system just to run down antelope assumes a level of hunting success that the fossil record simply does not support. So, what if we are looking at this completely backwards? What if we didn't lose our fur to become better hunters? What if we lost our fur to become harder to kill? Stay with me. Around 2 million years ago, the environment in Africa shifted dramatically. Forests were shrinking. Grasslands were expanding. Our ancestors were suddenly exposed, relatively slow, and highly conspicuous on the open plains. We couldn't climb trees to escape. We couldn't outrun most predators, unless we could outlast them. Predators hunt during the cooler hours of dawn and dusk. They overheat quickly. If you can keep moving during the hottest part of the day, traveling between water sources and shade when nothing else is active, you create a temporal niche, a safe window of time when the things that want to eat you are hiding from the sun. Sweating isn't just for hunting. It is for surviving in a predator-rich environment when you are too slow and too weak to fight. And this is where fur loss becomes absolutely critical for another reason: biological hygiene. Fur harbors parasites. Ticks, lice, fleas. Every parasitic organism thrives in a thick coat. In an open environment with larger, denser social groups, parasitic load would have been devastating to early human health. Hairless skin is easier to inspect, easier to clean, and massively reduces disease transmission. There is a reason we find naked mole rats so fascinating to scientists. They are one of the only other mammals that evolved to be hairless, and they did it while living in dense underground colonies where parasites and overheating are both deadly. Convergent evolution doesn't care about the path. It only cares about the pressure. But let's talk about the real reason this topic generates so much debate. Because there is one factor in human fur loss that scientists acknowledge but rarely emphasize: sexual selection. Charles Darwin himself proposed that much of human appearance could be explained by mate choice. If you look at fur loss through the lens of evolutionary psychology, the implications are profound. We didn't just lose fur, we exposed our skin. Skin that blushes, skin that flushes, skin that displays health or sickness, youth or age, fertility or exhaustion. We became biologically transparent. No other primate has this. A chimpanzee's skin is largely invisible under its fur. You cannot easily tell if it is healthy, ovulating, or injured. But humans? We broadcast our physiological state in real time. This isn't a bug in our evolutionary code. It is a feature. And features that expose honest signals of fitness are textbook sexual selection. Think about it. We have more pigment, variation in our skin than any other species on the planet. We have patterns of hair distribution that make absolutely zero sense for thermoregulation. Why do men grow beards? Why does hair texture vary so dramatically between global populations? These aren't just survival adaptations. These are advertisement adaptations. Once sexual selection kicks in, it can drive traits to extremes that make no pure ecological sense. A peacock's tail does not help it survive, it helps it reproduce. Our nakedness may be the exact same mechanism. But here is the twist that brings this entire evolutionary puzzle together. Sexual selection and natural selection are not opponents. They are dance partners. The cooling advantage of hairlessness created the initial pressure. Parasite reduction reinforced it. Endurance, running, exploited it. And then sexual selection took over, amplifying the trait beyond pure utility. We didn't just become functional. We became visually distinct. And that exposed skin had one final, monumental consequence that changed the trajectory of our species. It made touch possible, not just functional touch like grooming or fighting. Intimate, emotional, communicative touch, the kind that builds pair bonds, soothes infants, and creates profound social cohesion. Skin to skin. Contact releases oxytocin. It reduces cortisol. It literally rewires our nervous system for connection and trust. No other primate experiences touch the way we do, because no other primate has this much accessible, sensitive skin. We didn't just lose our fur. We gained a new sensory organ, the largest one in our body, and it became the neurological foundation of human society. So where does this leave us? With a messy, beautiful, overdetermined answer. We lost our fur because of heat, but not just heat. Because of running, but not just running. Because of parasites, psychology, and the profound human need for connection. Evolution doesn't have clean, simple stories. It has converging pressures, accidental consequences, and feedback loops that spiral into radical change. The naked ape isn't the result of one smart decision. It is the result of 1,000 small pressures pushing in the same direction until the old design collapsed and something entirely new emerged. And here is the final thought that should truly haunt you. We are still changing. Evolution did not stop. But in a world of climate-controlled buildings, tailored clothing, and advanced medicine, the selective pressures that made us naked are vanishing. What happens when the forces that shaped you disappear? Or, consider this, did we already engineer our way out of natural selection? We didn't need to evolve fur for the Arctic. We invented the parka. We didn't need to evolve UV resistance. We invented sunscreen. The naked ape became the dressed ape, and in doing so, we may have broken the biological feedback loop that created us. We replaced biological adaptation with cultural and technological adaptation. So the next time you look in the mirror and see that weird, patchy, mostly hairless body, remember, you are not looking at a finished product. You are looking at a work in progress that got interrupted, a story that started with survival, got complicated by psychology, and may have ended with technology. The only question left is whether we are the last chapter of human evolution or just the setup for something we cannot yet imagine.